In this lesson, we're again solving nonlinear systems. This time we're solving them algebraically as opposed to graphically. Our goal will be to find any point or points of intersection, and we'll do that by eliminating the variable y from the equations. The method involves substituting one equation into the other equation, thereby replacing y, leaving an equation only in x, solve the equation for x by one of the methods that we've learned in the past, factoring, completing the square or quadratic formula, and then once we found x, we'll substitute back to get y. I've got two examples to work out with you. The first one is a parabola with a line, and the linear equation is not isolated for y, so I'm going to do that by rewriting it as negative 2x minus 4. Now, think of it this way. What this is saying is that negative 2x minus 4 is y. So when I see y over here in the first equation, I can replace it or substitute what y is equivalent to from the second equation. I now have an equation in x, and this is a quadratic equation. I see the 1/2, so I'm going to multiply the whole equation by 2 to eliminate that fraction. So I've got x minus 1 all squared minus 8. Notice that every term is doubled. I'm going to expand this binomial square, which leads to that result, and you can see now all of the terms, including the quadratic term. We solve quadratics by gathering everything to one side. So this is going to be positive 2x, and this is going to be positive 1. Now, I recognize that this factors, so I'm going to write it in its factored form. Then I'm going to isolate for x by square rooting both sides. Square root of 0 is 0. And bringing 1 to the other side and saying x equals negative 1. I now found x. I'll use that to go find y. I'm going to use the relation here that y equals negative 2x minus 4. So that's 2 minus 4, and y equals negative 2. So my solution is the point negative 1 comma negative 2. And remember that a line and a parabola can cross 0, 1, or 2 times. In our case, we've only found one solution. So this line is actually tangent, just barely touching that parabola. You could use your graphing calculator to confirm that. Second example. In this case, I've got two parabolas. So we remember that that can have 0, 1, 2, or an infinite number of solutions. Now both of these equations are isolated for y already, so what I can say is that the first equation, what I just wrote, is y equals the second equation, and what I just wrote is also y. Y equals this from the first equation, y equals this from the second equation. Let's gather all the terms, bring them to the left side to make the squared term positive. It's going to be plus 5x, and it's going to be minus 12, and I've brought all the terms over. So I have a quadratic, and I'm going to try to factor that if I can. I'm looking for numbers that multiply to make 2x squared. That would be 2x and 1x. And two numbers that multiply to make 12. Well, 3 and 4. Notice that it's negative, so I need a negative sign. And when I do the cross multiplication, that's like the OI of FOIL. I have 8 minus 3, which is the 5 that I want. I read my answer as 2x minus 3. X plus 4. So this one happened to factor as well. Both of these examples factored. Sometimes they won't. Sometimes you'll need to use quadratic formula. This leads to the zero product rule, that if factor times factor equals 0, then one or the other factor must themselves be 0. Therefore x is 3/2, or x is negative 4. And because I have two x values, I'm going to get two corresponding y values. And I need to find out what those are. So let's find out what y of 3/2 is. Using the first equation, I could use the second one as well because this is a system solution, but I'm just going to use the first equation. And I'm going to substitute 3/2, and I get 9 over 4, 9 over 2, minus 4. My common denominator is 4, so let's rewrite these all with a common denominator of 4, and get 9 plus 18 minus 16 and that's going to be 11 over 4. So one solution point is 3/2, comma, 11 over 4. Now I've got to go get the other point. Using x equals -4, y of -4. So I'm going to substitute -4 into the equation for each location of x, and I'm going to simplify, and here I get 16 minus 16, or 0. So my other solution is -4, comma, 0. And this is a set of parabolas, or a system of parabolas, leading to 2-point solution. Again, you can confirm this on your calculator. That's the basics of how to solve nonlinear systems algebraically.